Yes. Yes. Good evening, everyone. Can we have a volunteer school to lead us in a word of prayer? A volunteer school that wants to pray for us. Yes. After school, you can unmute. After school, unmute.
Lord Father, we want to thank you for this moment. We want to thank you that you've enabled us to be in this online facilitation. Father, we pray that may you be with us so that we can master whatever that is going to be talked about today. Father, we pray for our facilitator. We pray for Mr. Kaziba who has prepared this meeting. We pray that may it be effective as we are preparing for our finals so that we can make it at the end. In Jesus' name we have prayed and believed.
Amen. Thank you so much for the word of prayer. And thank you so much, everyone, for joining. We are going to start off our session.
Good evening, everybody. Yes, I'm happy to be with you this evening. My name is Makum Edward Jack, and I'm a teacher from Ndeje SS. Where I'm going to share with you the basics of a physics practical. I hope you also have some idea about it. So this is the day. We are going to have like 2 hours of our discussion. We shall have a scenario, then we see how we write a report. How we write a report, all the different aspects about a practical. Then as we start the physics practical with the competency-based curriculum, usually you have areas where the items are picked: mechanics, optics, electricity. Those are the areas where the items are picked, but a paper has 2 items. These 2 items can be picked from any area. So it can be mechanics and optics, mechanics and electricity, or optics and electricity. So a paper has 2 items, but you pick one. You pick only one item, and the paper is for 2 hours. Yeah. There, items can be mechanics and optics, can be mechanics and electricity, can be electricity and optics. So any combination can be brought up, but you only select one item. During our practicals, we usually use instruments because it is about measurement of a quantity. It can be length, it can be time, volume, density, and so on. So these are some of the common mechanics apparatus. So those are some of the common apparatus. When you look at the picture, we have measuring cylinder, we have a meter rule, we have a beam balance, spring balance, stopwatch, and so on. Those are some of the apparatus for mechanics. Then for light, have a glass block, a lens, a mirror, bulb holder. Those are some of the items and apparatus we use in the practical. Okay, we can move on. Yes, so those are some of the apparatus for electricity. Ammeter with the a voltmeter, a switch, yes, the wires and crocodile clips. But we have others like connecting wires. You can also use the meter rule in the electricity practical to measure length and so on. So you can identify others. Now, I've said when we are carrying out an experiment, we measure quantities. These are some of the instruments we use. Students should be very careful about the accuracy of the instrument. The moment you lose the number of decimal places and you use others, it means that you lose accuracy, especially for the measured values. So we should be very careful as we record our values from the instruments. And usually they carry more scores. For example, when you look at the stop, the meter rule. When you look at the meter rule, we have 1 decimal place in centimeters. Here, 1 decimal place in centimeters. And the unit is a centimeter. But when you convert to meters, it is 3 decimal places in meters. We got a stop clock, 1 decimal place in centimeters. So whenever you use a stop clock, make sure that your value, which you obtain from a stop clock, is 1 decimal place in seconds. Then we got to the stopwatch. The stopwatch has 2 decimal places. So when you use a stopwatch, it must be to 2 decimal places in seconds. Let me go back to a stop clock. The last digit should be a 0 or 5. For example, you cannot get 26.3. It can either be 26.0 or 26.5, the stop clock. So its degree of accuracy is 1 decimal place, but the last digit should be 0 or 5. Stopwatch depends on what you read, but 2 decimal places. Measuring cylinder, here there's a small mistake. It should be 0 decimal places here, not 1 decimal place. It should be 0 decimal places in cubic meters. Now we got to, so we are editing that one. It should be to 0 decimal places. 0 decimal places. When you go to protractor, the protractor should be to 0. So whenever you're measuring angles, make sure that the number of decimal places is 0. So you cannot have 36.0. Whole numbers, you write whole numbers without a decimal point. Unit degrees, then ammeter, 2 decimal places, there in amperes, capital A. Even the symbols for these letters should be capital F for ampères because it is a name. It is a name of a scientist. So the symbol should be capital F. Also volt here. Voltmeter should be two decimal places in volts. Then a spring balance, two decimal places in grams. There are other instruments, but these are the common instruments. I selected some. Those are the common instruments. So please ensure that you record them to the right number of decimal places. The moment you don't record them to these numbers of decimal places, you lose the degree of accuracy and might affect your performance. So that is it. We go to table of results. Please, for table of results, the table should be closed. All sides, the table should be closed. When I say closed, uh, dictate. Okay. So we draw the table. When I say closed, it must be like this, down, then up. So all the sides and should be in column form. Should be in column form. So you must have columns, not in row form. The units must be in brackets, for example, centimeters, centimeters. So you put them in brackets. That's what we mean. Units should be in brackets. You only put units in brackets if the units are in a table of results. Please don't forget the table, all the values in the table should be written and drawn. The table should be drawn and the contents of the table should be written using a pen. Desist from using a pencil. You lose marks, you lose scores. All of values in the same column must have the same number of decimal places. So ensure that all of values in the same column have the same number of decimal places. We shall have an example. For example, here, so here, if you have this column one decimal place, all of values here must be to one decimal place. If the values here are supposed to be two decimal places, we expect two decimal places in the whole column. So always ensure that you follow that. Otherwise, you might lose if the values are not in the same, with the same number of decimal places. Then, let me go to another page. Okay, now we go to this table. If you can see the unit sign brackets, the table is closed, then the same for those of you for these values which I have indicated here, you can see they have recorded right now the same number of decimal places. Here, the values of V were measured using a meter rule. That's why they are to one decimal place. They are to one decimal place. So we want to check how do we get the values of UV? I'm requesting you to check, to test for me. When you are multiplying U times V, we first look for the pair which gives us the largest answer. I'm requesting you to check for me the pair which gives the largest answer. U times V. Can they reply? I'm expecting an answer very fast from anybody to send it. Where is the largest answer? Where is the largest answer? Somebody has told us 400. Is 400 the largest answer? Bukedia, yes. Buked College.
798.
Yes, 798. Yes, that is the largest answer. So let's see how do we record. Now here, is right. The largest answer is between 70.0 and 11.4. We use significant figures. How many significant figures are in 70.0? I want an answer from you. 70.0, how many significant figures? How many significant figures? Solid rock high. Yes? Solid rock high, Alua. Tell us, how many significant figures? We are not hearing you. Let's pick another one. Maybe you have some challenge in the network. Bwanga Secondary School. Bwanga Secondary School. Yes? Bwanga Secondary School. What is the, how many?
3 significant figures.
Yes, thank you. 3 significant figures. You deserve a clap. You deserve a clap. There are 3. There are 3 significant figures. Now, these ones are also 3. And the 70 is to 3 significant figures, 11.43. So our value of UV for the largest should be to 3 significant figures. What do you get? Somebody told us 798. So the value is 798. And 798 is to 3 significant figures. 798. $798. So those are 3 significant figures. Once you get the significant figure, how many decimal places are there? How many decimal places are there? I want a hand. How many decimal places are in 789? 789. Kagadi Academy. Kagadi Academy. Yes. Is muted. Kagadi, Sacred Heart. Chiterede. How many significant places? Sorry, 0 decimal places. Correct. 0 decimal places. You deserve a hand clap. Are you alone in the class? So, all other values all other values, all other values in this column now should be to 0 decimal places. So you'll work upon this, all values, because I said all values in the same column must have the same number of decimal places. So as you record these values, don't put a decimal point. Round off to a whole number throughout. So that is the rule. You first look for the pair, which gives you the largest answer. This was the pair, 70.0 times 11.4. The two numbers were to 3 significant figures. Therefore, the product here is also to 3 significant figures. When you express it to 3 significant figures, it is a whole number. Now the rest you maintain. It fixes the number of decimal places for the rest in the column. So let's go to addition. For addition, it is okay. You can start from anywhere. You don't need to look for the largest. You have 1 decimal place here on top, 1 decimal place. Our answer should be to 1 decimal place. So 20.0 plus 20.0, it must be 40.0. 40.0. .0 40.0. So all other values, yes, in that column 0. So all other values in this column should be to 0 decimal places. It should be to 0 decimal place. Sorry, to 1 decimal place. Because 40.0 is 1 decimal place. Now go to U over V. Let's work together here. For U over V, divide, look for a pair. Look for a pair anywhere, which gives us the largest answer. When you divide U by V, tell me the pair which gives us the largest answer. Check the pair which gives us the largest answer. Is it at the top, at the bottom, in the middle? Yes, we are seeing our lady. Our lady. Our lady. What is the answer? Our Lady Senior Secondary School. Our Lady. Unmute. You okay? Where? Which pair?
The last one.
The last pair.
One. Yes.
Okay, thank you very much. It is the last pair. Which answer did you get? Which answer did you get? Which answer did you get? Okay, when it the whole of it is 6.140350, but we need to round off to 3 significant figures. So that is divided by 11.4. That is the pair. To give us, must be recorded to 3 significant figures because both are to 3 significant figures. So even our answer is supposed to be to 3 significant figures. You round off to 3 significant figures. And we get 6.14. 6.14. How many decimal places are there? How many decimal places are there? Kakindo. St. Albert Kakindo. Give us the answer. Unmute.
Yes, sir.
How many?
There are 2 decimal points.
Pardon? Thank you very much. 2 decimal places. Yes, 2 decimal places. Meaning that all of values in that column should be to 2 decimal places. So that is it. I wanted us to look at how we manipulate values in the table of results. So I've looked at multiplication, we have looked at division and the addition. For division and multiplication, we first consider significant figures. The smaller number, if they are similar, you retain, you maintain. For addition, we consider the smaller number of decimal places. So I request you to complete that table. You'll complete that table. We move on. That is the summary. When adding or subtracting, the smallest number of decimal places are considered. Division or multiplication, we consider the least number of significant figures. I'm seeing a hand. Our lady, do you have any question? Yes? Or the hand remain there? Our lady?
Yes.
Mr. Facilitator, I'd like to pardon for me the table of results.
Of what? On what?
Table of results.
Table of results.
Yes.
We go back the okay, let's go.
Column, the last
Oh, okay, let's go back to the last column.
yeah.
Here. Okay, the last column here. U divided by V. When you are dividing U over V, you first look for the largest answer. Somebody divided for us. The largest answer was here, 70.0 divided by 11.4. 70.0 divided by 70.0 divided by 11.4. The number of significant figures for 70.4 is 3. And the number of significant figures for 11.4 is also 3. So our answer is supposed to be to 3 significant figures. So 70 divided by 11.4, the value was 6.140350877. But we want 3 significant figures. Therefore, we round off to 3. The 3 significant figures are 6, 1, and 4. But since 0 is below 5, we cannot round off. We just retain the value 6.14. But if it was 6.14, so that's what we retain. But if the value was 6.140, sorry, 6, 4, and we want 3 significant figures, we would count the 3 significant figures. It is 6, 1, and 4. But because the next number is 6, we round off and get 6.15. That's how it would be. But for this case, it is 6.14. So we write 6.14. That is the largest value in the whole column. That's why we started from there. So all other values are now rounded to 2 decimal places, like that. All other values now to 2 decimal places. So that's how we got the values. like that. How is it? Have you understood it now? It's off. Huh? Taiba, yes. What is your question? Taiba International School.
Good morning.
Good afternoon, yes, student.
I'm fine now. My question is, what if the column was U squared?
The same, we can include it. If it is U squared, we would
Can I go
look
to the
for the
series?
values of U, the largest. We would still start with the largest value of U. So what is 70? There are 3. 70 squared, 70 times 70.0, we get 4900. We want 3, we get 3, 4900. Now, this is a special case. That 0 at the end, we would not consider it as a significant figure, but we write it to keep a place value. Still, we would write 4900. Don't cut off the 0. If it is a whole number, don't write 490. The last 0 is non-significant, but it is keeping the place value so that we can still read 4,900. You cannot read a value which is 4,900 cannot become 490. So the last 0 is to maintain. Another trick we can use, whenever you multiply and get a large value, you just round off to 0 decimal places, or you record your value as a whole number, 4900. No problem, it would be fine. That's what we do. This figure is large, 4900. So we just write the values to whole numbers. There we don't take the rule of significant figures. For the 270.011.4, the value was large, but when we wrote it, it was still giving us exactly 3 significant figures. So there was no problem. But 4900, those are 4. But we cannot remove the 0. It would reduce our value so much to create a big error. So we just write all numbers. I don't know whether I'm understood. Yes, I'm seeing St. James. Bukedea. Bukedea, yes. Bukedea, comprehensive versus Bukedea.
Yes, sir. We had wanted to know on the side of UV, how many decimal are we going to include there?
For UV,
I was like, hey, on the side
0
of
decimal
UV,
places. You don't put a decimal
yeah,
place. So all other values would be to 0, no decimal place. Would write,
all
we are
right,
writing
sir.
for you. Would write the answer. The first one is 798. All other values, 0 decimal places. 720, no decimal point. 625. 528. 438. And 400. 0 decimal places. So that's how we would fill it.
So now, sir,
Yes.
which graph are we supposed to plot from there?
This is just an example. It is not an item. It was just an example. I just wanted to show you how we multiply, we add, and we divide. But we're going to have a scenario, and I will show you almost this. We have a similar scenario with the table of results. So I will guide you on which graph to draw. But currently, this is just an example of table of results. I cannot tell you which graph we are going to draw. I think we can move on. We can move on to another thing. We can go to the graph. I selected the two areas where candidates find it a little bit hard. The first one is a graph. When you're drawing a graph, it should have a title. But in the title, don't put units. Once you put units, that key point is lost. We can write a graph of y against m. Against m. Avoid writing the word graph. The word graph. That one where A is close to G. That one is bad. So no units. That is number one. It is a key point. Once you put units, you lose. So don't put units. Number two, axes. Axes. The axes should be drawn with units in brackets with arrows at the end. So when you draw an axis and follow the lines of the graph, if that is the arrow, it must have arrows. It must be labeled, for example, y in centimeters. There you put the units, y in centimeters, and m in kilograms. So we write like that. So ensure that the units are in brackets, and the symbol y, the quantity, should be in line with the centimeter. Don't separate the two. Don't separate the two like that and you put them down. No, that one is wrong. And the two lines must meet. They must meet perpendicularly. So follow one line on the graph paper. You follow one line on the graph paper. So that is about the axes. It is also a key point when a graph is being marked. Number three, the scale. When you find the scale, we label. We must mark the axes. Okay, let's go to the graph. Like that graph, we mark even after. So we draw the line, that line, the red line, you go through the line, then that one on the horizontal. So that is the line. Then you mark even after 2 centimeters. I'm showing how we mark. Even after 10 small squares, you mark. Don't mark even after 5. Even after 10. Even the horizontal, you do the same. Even after 10, there you mark. Even after 10, you mark. Even after 10, you mark. So that's what we call marking. Then the scale, we must use the following scale. Preferably 1, 2, and 5. But you can also use 0.5, 0.25, sorry, 2.5. But those are better. Submultiples, when I say submultiples, smaller than those 0.1, 0.2, 0.5, or 0.001, 0.01, 0.02, 0.05, or bigger ones like 10, 20, 50, or 100, 200, and 500. So those are the convenience scales. Each axis must have a starting value. For example, here, if it is 0, 0, you put a 0 there on the vertical, and also on the horizontal, you put a 0. So it is important to put a starting value on each axis, and the scale must be uniform. Let's use it 2 on the horizontal. So we use 2, you go to 4, you go to 6, we move to 8. That will be a uniform scale. We have used a single scale of 2. We are not changing. Then on the vertical, you can use 0.5. We use 0.5, 0.5. Then we use 1.0, 1.5, 2.0. So you can see that is what we call a uniform scale. It is marked every after 2 centimeters. The same on the vertical, you're adding 0.5, 0.5. On the horizontal, you're adding 2. Uniformly, we don't change. So that's what we call a uniform scale. Don't know whether I should teach you how to get the scales. But meanwhile, we can look at the plotted points. We use a dot and a circle, a small dot and a circle. Use a pen, not pencil. All these things we have talked about, table of results, graph work, should be in pen, not in pencil. So avoid using a pencil anyway on the graph. Even the title, the markings, the lines, the axes, and so on should be in a pen. So don't use a thick dot. Some people use a very thick dot, like that one. That one we might lose. Or a star. Don't use a star. There's that one. That is a star. Those who are in this class, let's use a dot and big crosses. Let's use a dot. Let's use a dot and a circle. That is better. And the circle should be a little bit small. Use pens. You can use pens like a Nataraj, Smile, because they have sharp points. Big might do, but its point is a little bit thick. It can make you draw a thick point. So I think we can go to line of best fit. Can go to line of best fit. Okay, go to the real graph. We are going to a graph. We have some graph where they draw. I'm seeing hands. Let me first answer some few questions before we move to the graph. Joy Dominion Academy. Very fast, ask your question. Yes, unmute. Louder. I'm not hearing. Yes. Nambieso Agro SS. Nambieso. Yes. We are muting you. Let's mute you. St. James. St. James. Any question? Oh, we are not getting it. So let's go back to the graph. Yeah. Oh, when you look at the graph, when you look at the graph, we see that spot. So when you look at the graph, the scale we have used of 0.1 throughout. I'm marking every after 2 centimeters. Horizontally, my scale is 0.05. That is a convenient scale throughout. You can see my dots, a dot and small circle. Then we draw a line of best fit. A line of best fit, it should average the points. Here it is going through 1, 2. On the upper side, it is leaving 2 points, and on the lower side, it is leaving 2 points. So that is a line of best fit because it averages the point. There are 6, it passes through 2, 2 on the right and 2 on the left. Now, so that's how we do a line of best fit. Where possible, draw a line which passes through most of the plotted points, but should average the points. If that one fails, average the points, even if it is going through 2, but 2 on one side and 2 on the other side. So that's how we do a line of best fit. Make sure that it goes beyond the last point and the first point. Then the next thing is the method of determining the slope. We draw a triangle, a big triangle. Where possible, draw a big triangle. It should touch 2 points. It is touching here, and it is also touching here. So it should touch 2 points of the line of best fit. Then you read them accurately. When you look at the horizontal, the scale is 0.05, but where each small square is 0. Each small square is 0. Each small square horizontally is 0.005. Is it? Yes. Then vertically, it is a scale of 0.1. That is horizontal, 0.1. But each small square, since they are 10, is 0.01. Then when I'm recording, I record the horizontal coordinates to 3 decimal places. Because each small square is 3 decimal places, that's why down you are seeing 0.470 there. Those are 3 decimal places. And vertically, you are seeing 0.850, the horizontal for the second pair, 3 decimal places. Then horizontally, vertically, it is 0.012 decimal places. I'm reading 2 decimal places. I record that value. Even there, it is to 2 decimal places. So when you're recording those coordinates, you first determine the size of each small square, horizontal and vertically. They will determine the accuracy of the coordinates. It is important. We have shown you 3 dp from the small square, then 2 dp from the smallest square vertically. So as you read your coordinates, you should put that one in mind. Otherwise, you cannot pass the slope. I'm seeing hands. Let me try to answer some of the GRTSS. Yes? GRT? GRT? Kihihi? Kihihi, please. Kihihi, unmute. Chinyala, now I'm picking Chinyala SS. Chinyala, yes. Oh no. Yes?
Yeah. So,
Uh-huh.
Master, we are asking
Yes.
a question.
Ask,
We are
ask.
requesting to. So we are asking to pardon on the how to get the number of the decimal places in each point on the slope when you're determining the largest
Mhm.
I hope you have got my question.
No.
So my question is where you have written the 2dp and the
Okay.
other side 3dp. That is where I'm trying to ask. We are
I'm
requesting
going
for
to
a
ask.
pardon.
Don't mute. I'll be asking you. What is the scale horizontally?
The scale horizontally
Eh,
is 0.05.
0.05. It is 0.05. What is the value of each small square horizontally?
Value of each small square is 0.005.
Okay, 0.005. How many decimal places are those?
Those are 3 decimal places.
3 decimal places. So that one determines the number of decimal places for values of the values of the coordinates horizontally. That's why it was 0.47 when you read it. It's 0.47, but I have to add a 0 so that I make 3 decimal what? Places. So that's why I'm recording 3 decimal places, because the smallest square is 0.005, and those are 3 decimal places.
Yeah.
Understood, sir?
Oh yeah, thank you for that.
Vertically, let's go vertically. What is the scale for vertical axis?
It is 0.01.
0.01, eh? 0.01, 0.1.
0.1.
Eh? What is
0.1.
yes? What is the value of each small square?
Value of each small square there is 0.01.
How many decimal places are those?
2.
2. So that's why we are recording the second coordinate to 2 decimal places, because it's from the vertical axis. And I think you have helped. I think you have also helped others. That one I want to move on. So that's the reason why we are recording to 2 and 3.
All right.
Okay. Mute. Move to another. So I want to show you how we read the slope. How do we record the slope? Let's use the same example. I'm going to use the same example. So we are going to record our values. The slope is equal to 1.52. That is the upper coordinate. That one. 1.5 minus 0.92 over then the horizontal coordinate 0.850 minus 0.470. So we are subtracting the upper. It is 1.52 minus 0.92. We find that it is 0.6. But we don't write 0.6 because the two values we have subtracted have 2 decimal places. So we must add a second decimal place. That's why I'm writing 0.60. Then at the bottom is 0.850 minus 0.470. We find that it is 0.38. 0.38, but we don't write 0.38 because there were 3 decimal places. So we add a 0 to make 3 decimal places. Now, when you are dividing, consider significant figures. 0.68, 0.60 has 2 significant figures. 0.380 has 3 significant figures. We take the least, which is 2 significant figures. So when I divide 0.60 divided by 0.38, I find that I have 1.578. 1.57894. Let's stop there. So I want two significant figures. I round off. I write 1.6. Those are the two significant figures. We take the smaller one. We had 2 and 3. So our final answer must be to two significant figures. So that is it. Are there hands on units? Now, the other one was a volt. On the vertical, it was a volt. And on the horizontal, it was amperes. So the unit is volt per ampere. We can write that. But volt per ampere is the same as ohm. So we could say 1.6 ohms. Because when you divide voltage by current, you get resistance. So its equivalence is an ohm. So that's why you have written ohm. Any hand? Yes. Ocassia, girls. Girls. Yes, our girls. Can you ask your question? Ocassia girls. Panyimul? Panyimul.
Hey, thank you, sir.
Uh,
I'd want to ask this question about the use of pencil on the graph.
uh,
What is the penalty after
Hello?
me? What is
the
the penalty after me
penalty.
using pencil?
The penalty when you use a pencil on the graph.
Yeah.
For example, if they are plotted points, all of them are not considered. You lose all the plotted points. There are areas where we can consider pencil, but my advice is, because when you're in an exam, because of pressure, you might end up using a pencil where it is not supposed to be used. Let's use the pen. Because the pencil, especially the plotted or writings, not allowed. So my advice, let's use a pen.
So, sir,
Let's have, yes?
I'm having one more question about the title of the graph.
Uh-huh.
When I'm
Yes, I didn't
writing
ask
it,
that question. The thing is,
when I'm writing in capital letters, am I
Uh,
allowed to underline
Yes,
or
I.
when you title
Eh,
Miss
message?
Eva.
yes, I.
to,
Miss Eva.
What's this, I guess?
Teacher girls.
you can write in capital letters, but it's a little bit hard for us to write in capital letters. So my advice is use small letters. You're talking about underlining. Use small letters.
Yeah,
Small
like
letters are
it.
better.
Any question?
Because I raised the hand, open, the thing is refusing to mute.
You are many. It is open for many. I'm seeing very many schools asking. Hihihi, ask.
Thank you, sir. My question is, pardon, on the type of results, my question is that on UV plus V, pardon there, sir. Elaborate.
UV. Okay, we shall go back to UV and we shall have another example on UV. We're going to use another example. At the end, we shall revisit it. Okay. We can go to, I think you're going to scenario. One more question is single secondary.
Hello.
You single?
Yes, hello.
Yes.
Sir, would like to know one thing about the graph you were plotting. There's something where you indicated like the three DPs
but we didn't get that clearly. And secondly, is it required for us to put the scale that we're using on the graph? Is it marked?
No, you don't need it. You get the mark for the scale, but even if you write it there when it is not proper, you don't get a mark. So it is the teacher will look for your scale by considering very many conditions. So that's why don't waste time writing it, because the teacher has to find out, is it uniform, are the axes marked, do you have starting values, and so on. There are very many things. So writing it, you might not get a score if you have not fulfilled this conditions. So you don't need to write it. Even if you don't write it, but it's okay, then you get your marks, you'll get your score.
Okay.
Remain online.
Okay,
Remain, don't mute. Don't mute. I want to ask you some questions here. Are you seeing the graph very well?
Yeah, and
I'm on the graph. You are asking the number of decimal places.
yes.
Now, horizontally, what is the scale?
Yes, sir.
Horizontally, what is the scale?
0.05.
Zero what?
0.05.
That is the scale. Good. But there are 10 small squares. What is the value of each small square horizontally? We divide it by 10.
0.005.
0.005. That's why the coordinates which are on those obtained from the horizontal axis should be to 3 decimal places, because 0.05 is to 3 decimal places. So when you got the coordinates, that's why you have 0.580, 0.5, 0.850, 3 decimal places. Even down here, it is 0.470, 3 decimal places. That was the reason. Then even vertically, you do the same. The scale is 0.1. Vertically, the scale is 0.1. We divide it by 10. We find it is 0.01. And those are 2 decimal places. That's why the vertical coordinates are all read to 2 decimal places. That one and that one. So we can,
Thank you very much, sir.
Welcome. We can move to, we're going to look at that scenario. Let me give you 2 minutes to read through the scenario. Your neighbor's phone charger stopped working because the small fuse inside it was damaged. As a replacement, the neighbor bought a new fuse from the market, but the neighbor is unsure whether it will protect the charger properly. The best fuse should have a resistance in the range 1 ohm to 3 ohms in order to optimally protect the charger. Your neighbor asks for your help to confirm whether the available fuse serve the purpose best. The available fuse is labeled X. Carry out a scientific investigation to advise your neighbor whether the fuse will protect the charger. So that was the scenario. Usually the scenario has a problem. The problem is this neighbor wants to know whether it will serve the purpose, like the damaged one. So you need to help him. You need to help him. So when you are carrying out a scientific investigation, you write a report. So we are going to see, how do you write a report for this scenario? How do you write a report? We need the aim, hypothesis, variables, materials, procedure, table of results, graph, slope, errors and precautions, then conclusion and advice. So that's what you're going to look at. Sure. Okay. Maybe I would have asked you. I would have asked you, what is the aim of that experiment? Let's go back. What is the aim of that experiment? Aim. Who can tell us the aim of the experiment? Yes? Georgia William? Rhino Camp Secondary School. What is the aim of the experiment? Mazzolidi? We are moving to Mazzolidi College. Mazzolidi College? Yes, your hand is up. I will expect you to tell us the answer very fast. Mazzolidi, yes. Yes?
Master.
Yes?
Yes, Master. The aim is
yes.
Master. The aim is an investigation. Yeah? The scientific investigation to determine the basic use that have the resistance.
We are hearing you.
Yes. The scientific investigation to determine the fuse that have the resistor in the range of 1.8 ohms.
Mokono comprehensive. Mokono comprehensive.
Yes. Good afternoon, sir.
Good afternoon, how are you?
Okay. The aim is an experiment to investigate the resistance of the fuse.
Yes.
Yes.
That is it.
I can try.
Oh, another person try.
Not the S.4.
Yes.
Is it me? An experiment to determine the.
They are listening. They are listening.
Yes. Okay, let's use this as an example. An investigation to determine the resistance of a fuse. That is the scientific aim. This is the scientific aim, an investigation to determine the resistance of the fuse. Usually the aim has two parts. Then the other part is the purpose. Why are you finding the resistance? To confirm its suitability in the phone charger. So that will be the purpose. Or to confirm whether the fuse will work effectively in the charge. To confirm if the fuse can protect the charge. So there are very many ways, especially for this scenario. But the main aim was to investigate an investigation to determine the resistance of the fuse to confirm its suitability in the phone charge, or to determine if it will work efficiently in the charge. So that is the aim. Then we go to the hypothesis. Now for the hypothesis, you write this statement. It can be mass, the acceleration due to gravity, or the mass of the wood is, and then the value. So it must have a quantity and a value. So in this case, we have resistance as the quantity of the fuse is in the range of 1 to 3 ohms. The variables we have independent variable. When you look at the diagram, you shall find that it is the length of the bare wire. If you have labeled it L, it is better you write it there. The length L of the bare wire. Because the length of the wire might be big. So it is better you specify which length. Then that is the independent. Then the dependent, either voltage or current. One of the two. We give one example, control the variable. In this case, something which by the dependent is a result of an independent being changed. When you vary the independent variable, what is affected? It is the voltage or the current. That's why it depends. A dependent variable changes as a result of adjusting one of the variables. The one which is adjusted first is the independent. Then the controlled variable is EMF, material of the wire, and temperature of the wire. You pick one. We just need one example for each. Don't need many. Then the materials, now, this is not necessarily needed, but you can put them there, but it's not a key point. It's not a key point. Okay, that's what I wanted to say. The diagram, the setup is a key point. For the setup to be valid, it must be a working diagram. A working diagram is the one which will give you the results which you want. For this case, the voltmeter is connected across, the voltmeter is connected across, yes, across the fuse. In case you change and you put here the ammeter, your diagram becomes unworkable. So everything collapses. Even the steps will not be marked. So it is better you draw the right diagram. Correctly label your diagram. Now you get one key point for the diagram. So that is the diagram, one key point. We go to so the circuit was, we use past tense. You say was connected as shown in the figure. Then the length L, was adjusted to 10.0. So when you look at this 10.0, because you're going to use a meter rule, it is better you record to one decimal place. 10.0, using, whenever there is a quantity which has to be measured, you tell us the instrument using a meter rule and then switch case. Don't forget, because when you look at the diagram, the switch is open. So for you to get results, you must close the switch. The ammeter reading I and voltmeter reading V were read and recorded. Here, already you have told us the instrument, voltmeter reading and the ammeter reading. So we shall know that it is from the voltmeter and this one is from the ammeter. So in this case, although it is a measurement, but the instruments have been mentioned, so that is okay. Then the switch was opened. That's another step. Steps, don't say procedures. You say steps B to D. By the key steps here, part B. That one, for every experiment, you must have this step. The length can be mass, can be volume for the first. The next step is repeating. That is also all procedures must have repeating for values of L and so on. Where possible, this value should be 6. Go for 6 or 5. Already you have 10, 20, 30, 40, 50, and 60. Then results were tabulated. That is also important. The results were tabulated. Then a graph. All experiments we shall carry out, you must plot a graph. So you must identify which graph. Since you are finding resistance, you plot a graph of V against I, because the slope of V over I will give us resistance. The slope S of the graph was determined. In most cases, we determine the slope. We determine the slope, then slope, the resistance, that is the conclusion. Because after getting the slope, that slope is the resistance of the fuse. Always the last step must show us how we determine what we want. If it is the mass of the meter rule, at the end you say the mass of the meter rule is. If it is density, you tell us the density of the liquid is got from this. So once you write all these steps like this, you get some key points and coherence. There is a key point of coherence. When all your steps flow logically, then it means that there is coherence. You get that key point automatically. Once they are not, if you skip an important step, then coherence is lost. You lose the score. So it is important to write them well in the right order. Then table of results. Here we have the table of results. That is our table of results. Just as an example. The good thing with this one, it has no manipulation. The values of I, 2 decimal places. The values of V, 2 decimal places. The trend, here we consider the trend. When you look at I, the values are supposed to be decreasing. And V in this experiment, the values are supposed to be decreasing. So the units are put in brackets, A, capital V, centimeter, they are put in brackets. So that's the table of results we would have. But you might not get the same results. Each candidate can get his own results, but close to that. That was the graph. The graph from the experiment we have talked about, from the table of results. Horizontally, the scale is 0.045. Vertically, it is 0.1. In fact, it is the other graph we have discussed. That is the graph. Okay. So when you look at, that's how we got our slope. In fact, we have already discussed this. We got that value. That's the value we got. That one I've already discussed. We got that 1.6. Then the conclusion. The resistance of the wire or the fuse is 1.6, which is in the range of 1 to 3. That is the. Then you advise. I advise my neighbor, or I advised my neighbor not to buy the fuse. So, sorry, to buy the fuse so as to replace the damage on the phone charge because it was in the range. That is the conclusion. The conclusion is the resistance of you must conclude by looking at the result. Then you compare with the hypothesis 1.6. Is it in the range 1 to 3 as stated in the hypothesis? Yes. Then advise buy. If it was out, like here, it is out. the resistance of the fuse, if it was 5, this is just an example. You would say, conclusion, the resistance of the fuse is 5 ohms, which is not in the given range. I advise my neighbor not to buy the fuse to fix it in the phone charger, but to look for another fuse. That will be the advice. So that is how conclude and advise. It is a must after getting that advice accordingly. We go to errors. Please, I'm advising you, write the report the way you write it at school. You might not follow my order. Provided you include all of these, don't use my order. Don't grab my order. You can use your own order. But always start with the aim, hypothesis, variables, then set up like that. So parallax, don't just say parallax. Don't just say parallax. You say parallax error when measuring the length of a bare wire on a meter rule, when reading current from the ammeter, or when reading voltage with the voltmeter. So you tell us the instrument where parallax is. Then precaution, ensure the eye is directly above the scale of the meter rule, the ammeter or voltmeter. Number 2, errors due to loose connection is at the terminals. Then I'm seeing a hand. Then when it is loose connection, ensure tight connections at the terminals. Errors due to heating of the wire. Then by switching off the circuit between reading. After taking the reading, switch off. Because when you leave it on for long, the wires are going to experience resistance and they will heat up. Then running down of cells, switching off the circuit between readings. We only need 3. You don't write all of these. Just pick 3. You write, and each error you have written should have its corresponding precaution. If you have an error which you don't have its precaution, don't write it. Write an error where you can easily give us the precaution. So 3 are enough. Don't go beyond the 3. Don't go beyond 3. That will be enough. So can we have some people who are, can you answer some? Let's have Georgia William. Georgia William? Yes, Georgia William? Rafik.
Good evening. Good evening, sir.
Good evening. How are you?
I'm okay. My question goes.
Good evening. How are you?
I'm fine, but I would like to know when we
Your
are
internet
calculating.
connection.
When we are calculating the slope, we didn't use the formula of the slope.
The formula, vertical change divided by horizontal change. That one.
But I would like to know the formula of the slope.
Did you study gradients in math?
Yes.
Okay, we use
the
that
way we
formula.
calculate the gradient, vertical change, let me just say that vertical change divided by the horizontal change. But we don't need to write it. You just get the coordinates and find the gradient. The way you get gradients of math is the same way you get the gradient, provided you have the 2 pairs of coordinates. Just find their gradient, you'll be finding the slope.
Okay, sir. Thank you, sir.
We are giving an example there. Look at that example. Example is there. 0.40 and 0.92. So to get the gradient, it will be the vertical change. Gradient is the same as slope. Vertical change divided by horizontal change. The vertical change is 1.y2 minus y1 over x2 minus x1, which is, that one is x1, can say x2, y2, and we call this an x1, y1. So you can use that 1.52 minus 0.92 over 0.850 minus 0.470. And the rest will be discussed.
Yes, sir.
Yes.
Teacher.
Yes.
Another question, eh? So for us this side, we have been advised that when you're drawing this graph, you leave 2 centimeters from the margin, then 2 centimeters like from the bottom. But here we are seeing that for you, you've left only 1 centimeter.
Leave 2 centimeters.
If you use the 1 centimeter, yes?
There's no problem. You can leave your 2, don't change it.
Okay.
But even 1 has no problem, provided the space is enough for you to write.
When you are writing this,
Okay,
who's
sir.
asking you?
Yes, master.
Yes.
Another question is, when there is no need of writing the scale in this graph.
No, you don't need. You are wasting. You are dirtying the paper. You don't need to write it. You don't need to write it. You will get your mark. Don't get worried. Even if it is missing, the teacher is going to look at your scale and you get your mark. Even if you don't write, because you might write it and where you have written it, that's where the point is going to be.
Okay, master.
Yes.
Now I'm seeing this color in which you have used it to find the slope. What do you base on to draw this angle?
The bigger, the better.
Yes.
You try to draw a very big triangle covering most of the points.
You base on what, master?
That one. I think what I'm showing you.
Yes.
So pick a point whereby all the points are all inside, if possible. All the points must be inside the triangle. Then down also do a large line there. So ensure that it is covering at least 50% of the graph paper.
Yes, sir.
Another question.
Yes.
The
last one.
Master, this line you have plotted, is it a master that it can pass here at 0 point?
The line of the triangle or the line of base fit?
This one, the line we have plotted, the line.
It can pass through the origin, but don't go beyond it.
Is it a must or
no?
Even if it passes here, like yours.
It is not a must.
Okay. Thank you, sir.
Thank you. Should you ask more? Busembatya. Okay, ask sir your question.
Master.
Yes.
Hello, sir.
Hello, how is Usembatia?
Sembatia is okay. How is there?
We're enjoying this side.
Okay, that is good. Master,
Yes.
the question I'm asking,
Mm.
my graph on the graph paper, what must be the maximum coverage?
50%.
Or which space? 50%.
At least 50%.
Okay, sir.
But if it fails, you go with, provided your scale is uniform and the points are plotted well, you don't lose. You don't lose a lot. In fact, you might lose just one or not. The key factor is it uniform? Is your scale uniform? Are the points plotted correctly?
Master, what you mean the coverage doesn't matter?
Does not, it matters, but not so much. But if it should be 50%. But what if it fails and you're finished drawing the graph? You continue.
Thank you,
But
sir.
it should cover at least 50 and above. Make sure that your points are covering 50 and above.
Okay, sir. Thank you.
Welcome.
Excuse me, sir.
Yes, from where? Which school? Huh?
Sir.
Yes, you can talk.
Yeah, about the line of best fit. You're
Uh,
saying that the line has balanced there, but me, I'm seeing on the lower side, it has touched the other point. So you mean you only count points which it has passed through directly in the middle, or even you count the one which it has touched? Because down I'm seeing the
you count those where it has passed
exactly
directly.
in the middle.
In the middle.
So you're counting two down because I'm seeing the other one is being touched by the line and you're also counting it.
I counted it two. Then the two on left and two on the right. Can you continue? Yes, the last item. In your community, a businessman runs a local video show center where people gather in the evening to watch movies and football matches using a projector. Recently, the image of the screen became very blurry, and after checking, he realized the main convex lens of the projector is broken. The projector manual specifies that focal length of the lens must be between 10 and 20 for the projector to form a sharp, bright, real image on the screen. The businessman went to a supplier and bought a convex lens, but is not labeled with low focal length. He asks you to help verify whether or not the lens matches the projector's requirements. Use the convex lens in your physics laboratory to confirm whether it is the type within the recommended range. Now, can you tell me the aim of this experiment? Aim. Aim? Yes, our lady. Or Gavania High School.
Good evening, Master.
Good evening, hi.
Master, I was asking that is it a must to put the errors and precautions in the table, or I can specify and give any error with any precaution?
Yes, you can do that, but the table shows is better. You might not forget, but you can write it provided you provide for us with the precaution.
Oh.
Give us the aim before you go away for this scenario.
The aim.
Hey.
The aim.
Hey. You are running. I will pass it to the neighbor.
No, master. I'll try.
Try. That's good.
An experiment to determine the focal length of the lens.
Convex lens. Good. What is the purpose? Why you determine the focal length?
In order to in order to confirm whether it is in order to see whether it's the type within the recommended range or to be put in the
or in order to replace the broken one, the project.
Yes.
In order to confirm its suitability in the projector. Yes? Yes.
Master, I had another question.
Yes.
Is the errors and precautions put after the variables or after the step?
The order does not matter. You can put them after the table of results. You can put them after the variables or hypothesis. Please, the order does not matter. But have you written them? And I suspect that this year, you even be given on your question paper how to write it. They'll give you the different aspects. They say aim, hypothesis, variables, precautions, errors. So if they are given on your item, on your question paper, you write them using the order given to you. You are likely to have the order given to you. So when it is given to you, use that order.
Okay,
so let's continue. Let's continue with an investigation to determine the focal length of a convex lens in order to replace the damaged one in the projector. So the aim is to determine the focal length. The purpose is to replace the damaged one. So that is it. We go to hypothesis. The focal length of a convex lens lies in the range 10.0 centimeters to 20.0 centimeters. Then that is the hypothesis. The variables, independent variable is the object distance u, because that's what you first change. Dependent variable is the image distance v. Controlled variable is light intensity or amount of light or nature of the lens. Now, this is the setup. A torch, a convex lens, a lens holder, white screen. You can use this setup, or you can use where you are seeing the torch bulb and you put the screen with wire gauze. The same thing. No problem. Now, the apparatus were arranged as shown in the figure. The object to you was adjusted to 20 centimeters using a meter rule, and the switch was closed. The white screen was moved to and fro using until a sharp image of the torch bulb. For this experiment, we use a torch bulb. We don't use a wire gauze. So until a sharp image of the torch bulb was formed on it, the image distance between the lens and the white screen was measured using a meter rule and recorded. Steps B to D were repeated for values of U. The values of U are given. Then the results were tabulated using tabulated, including values of UV and U plus V. A graph of UV against U plus V was plotted. The slope S, let's move this. The slope S of the graph was determined and was calculated. Then the slope is the focal length. That is the conclusion. The slope S is equal to the focal length of the convex lens. So that's how we get it. Then that was the graph. Already we have discussed about such a graph. Sorry, that is the table of results. Already have discussed this table of results. So that was the graph. So you find time and plot this graph. That is the line of base fit and so on. When you determine the slope, when you determine the slope, we got 14.8 centimeters. So we now conclude. What conclude? You said the focal length of the convex lens is 14.8 centimeters, which is in the range. Therefore, the hypothesis is accepted. I advise him to use the lens in the projector. Those are the sources of errors, especially 1 to 3. 1 to 3 parallax when reading meter rule. Precaution is that place the eye perpendicular to the mark on the meter rule. Too much light in the room, put curtains on the doors. Lens sagging in the holder, fixing a lens using plasticine. You can now ask questions. Nabieso agro SS. Can you put forward your concerns? Nambeso. Masindi Secondary School. Masindi Secondary School. Masindi Secondary School. Yes. Ask Masindi Secondary School.
Hello.
Hello.
Okay, our question. Okay, I will read just clarification. Like on the end, they had told us that when you put in the end, you have to put that thing whereby there is in the range of, let me say, 1.0 ohms to 3.0 ohms. They had told us that you should put that there at the end. And yet for you have not put it. And even in the hypothesis, they had told us that you have to put even the hypothesis, but you have not put that.
Not necessary. For the hypothesis, it is not necessary. The hypothesis, just put the quantitative focal length of the convex lens is this. Because it will be a repetition. You have already put the purpose in the aim. But in the aim, it is a must. It is a must. And in the conclusion is okay. You can say the focal length is 15, which lies in the range of 10 to 20. Then I advise him to use the lens in the projector.
And another thing about the variables, like they told us that we put the variables like how you had put them. It's like you're tying them. I don't know if you're going to understand what I mean by tying them. But
you are doing what?
like on the variables, when you list them the way you had listed them, it's like you're tying them. Like if you put them in the same line, the answer does that pass right, independent, control.
Remain online. I want to show you. Let's go back and see what you're asking. There. Wait, what is now ask?
There, like how you had those variables, you have put them in that same line. Like you have put the independent variable as
Oh. They should not, you put a heading. Okay, I've understood it. You want to put the heading independent and down you write object distance you.
You first write independent, dependent, control, then after that you write down object distance, image, and ID testing.
No, you'll be disturbing the teacher who is marking your work. Immediately, the moment you put independent variable, put the example. Dependent variable, put the example. That one is the best. But don't just first write independent, dependent, controlled, and down, then you put the examples. No. Put independent and the example. Dependent and the example immediately.
What of the
What about what?
Does it?
Yes. Are you still with us? We are going to mute you. Now, since we are done, we can have some few questions now. We are entertaining some few responses from you. Byarugaba, Byaruhanga.
Good evening, sir.
Good evening, how are you?
I'm fine. Now, teacher,
Huh?
I want to know on balancing the graph.
Balancing what?
The graph when you are drawing. For us, teach that the advice says here that you balance, it must be equal. Now there.
But
I want straight. Another question. It is about the graph. It's about of voltage. You repeat at the extreme of at the axis. Can't you put them in the middle?
From mid and upwards, see? Mid and above. You can write it from the mid and above. Then about balancing, at times it can fail. It can fail. You can fail to balance. If you have 5 points, for example, how will you balance them? It can fail provided the line averages. You try, because you can have 2 and 1 on one side, 2 on the left and 1 on the right. That one is also acceptable. So it is not a must that they have to balance, but you try your best to average the points. That is the most important thing.
Teacher, again, question is about that one. The experiments about electricity. Before we determining, for example, the internal resistance of a cell and EMF in procedures, did they differ?
They don't differ so much, but the only difference in the procedure is the diagram. Here, the voltmeter is connected across the dry cell. If you are determining the internal resistance, the voltmeter is connected across the dry cell, but the rest will be the same. The other procedures, even you draw graph of V against I, but the slope should be equal to negative R because it's going to have a negative slope.
Thank you.
Chinyareses.
Are you penalized? Are you penalized when you write procedures instead of
Good evening. No, but we should not wait to be penalized.
then on the purpose, the hypothesis. Why don't we write the purpose on the hypothesis?
Now, students, I don't have any problem, write it, but for us, we shall only look for focal length and the value. Internal distance, but when you write it, you don't lose anything. Since you are used to writing this thing, write it, but the teacher only look for the what he wants.
Okay, thank
you. Good evening, sir.
Good evening, how are you?
We have a question here.
Yes.
We were guided here that we do.
We do what? I've not heard, Rafik.
We were told here that on the table of results, we should draw only three.
Three what? Three columns.
Yes.
It must be in
It is not a must. There are some experiments which have more than three. You have U, you have V, you have U plus V, you have UV. Yet you need the U plus V and UV. By all means, they have to be more than three. So although most of because like finding the spring constant, you cannot have only three. You have the mass, you have the position of the pointer, nu, you have the extension, you have to convert the mass to weight. So that column must also be there. If you have to use weight, again, it's extension. So don't cram that you have to be three. Don't cram, please. Yes, let's have motto. Sacred Heart Chiteredde. Chiteredde is where? In Masaka?
Yes, sir.
How
Good
is
evening,
Masaka?
sir.
How is
It's cool.
Masaka? Huh?
Masaka is cool.
Cool?
Yeah.
Ask your question, Sacred Heart.
So, sir, you talked of when dividing, we use the list number of significant figures.
Perfect.
So, let's say I drew a graph of U over V against U. I'm finding the focal length.
U against U?
I said
U
U over
against
V.
U.
U over V against U.
Yes.
So here they say the focal length is 1 over the slope. So do I use 1 as the significant figure, or I use the slope, the significant figures which I got in on the slope?
Hey, 1 is a float. It's just a constant. So we don't look what its number of significant figures. We just consider the number of significant figures in the slope.
Thank you, sir.
Okay. Another one?
Sir.
Yes.
If I use a graph of U plus V against UV, am I allowed to use it?
Yes. In that case, the slope is 1 over focal length. It is the reciprocal. You can plot a graph of U plus V again.
Another question. When I'm writing when I'm writing the what? When I'm writing the heading on the graph, am I allowed to put it inside the graph?
Inside better. On the first line inside.
The scale. Am I supposed to use 2.5?
Yes, you can use 2.5.
Okay, thank you, sir.
Have
a nice
Any other? Girls, Logiri girls.
Sir,
Yes.
are we not supposed to write the reason while stating the hypothesis?
I've allowed you. You can use the reason. You can add a purpose. Add the purpose. You can add it. You don't lose anything when you add it. Pardon?
You must try. That's the reason.
You say the focal length of the convex lens
Hello, sir.
is in the range, so it can be used in the projector, replace the damaged one.
Okay, thank you.
Welcome. Another one, another person now. Bessero. Bessero Secondary School. Solid Rock, Queen of Peace.
Question is now.
Solid Rock
Good evening. Good evening, sir.
Good evening, how
I
are
would
you?
like to inquire about the graph. Like when my plotting points can't fit on the graph, is it okay when I consider 1 centimeter?
No, you choose another scale. If you had used the 2, use now 5.
Still, sir. How
You go
about
to a
when
bigger scale.
I've chosen another scale and again it can't fit?
It means that you use the poor method to choose the scale. Get the largest answer value minus the smallest value on the vertical divided by 10, on the horizontal divided by 8. When you use that method, you will not fail to get the right scale. Another person? Hawal.
Excuse me, sir.
Yes. Talk, please.
Hello. Excuse me. Hello.
Yes. Hello.
Yes, sir. Here we have some question. You have been talking about the hypothesis, and we were told that we have to include a purpose on the hypothesis, and they say that it is a must. So,
I have allowed you. Include it.
Okay, sir. Thank you very much.
Yeah. You're welcome.
Hello. Hi. Hello.
So students, we have come to the end of our session. Thank you for being good students. And when I get another opportunity, I'll come and share with you more physics. But may God bless you. I wish you success. If we don't meet again, I wish you success in your exams. I remain Makumbi Edward Jack, a teacher from Mundeje SS in Ruwere. Nice time.
Thank you so much, Teacher Makumbi, for the wonderful session you have offered to the country this evening. Thank you so much, other schools that have joined in. Allow me to invite the Principal Education Officer from the Ministry of Education, Mr. Ronald, to say something and then to officially close off the session. Mr. Ronald, you're welcome.
Thank you, Mr. Kazuba. Can you hear me?
Yes, Mr. Ronald, you are very clear.
Yes, I would like to thank Mr. Makumbi for the job well done. I have tried to follow through, and I wish I was a candidate going to sit. I think I would be ready for that practical paper. I want to thank you so much and wish that you continue preparing so that next time when we call you, you still come back and support the candidates in this country. To the candidates, I want to wish you the very best. I know that this is the last week you have to prepare, but I'm more than sure that you are getting ready and ready for the exams. I want to wish you the very best and thank your teachers for bringing you online, but also continue listening to the videos that are recorded so that you prepare well. Thank you, Mr. Kaziva and your team for this activity, and wish everybody a good evening. Bye-bye.
Thank you. The teacher from Buanga kindly take for us some photos. Rhino Camp also take some photos. The teacher from Buanga kindly share with us a photo. Logili Girls as well, Our Lady Senior Secondary School, Itula. Yes, those teachers still on a call, kindly take for us some photos and then you can share with us. Otherwise, thank you so much.